it's repeating, okay. It's repeating. So if any number that can be expressed as a fraction is a rational number, it's a rational number. And you should see some irrational number, okay, irrational number. And you should also see irrational number. Irrational numbers are numbers that cannot be represented as a fraction. So if a number cannot be represented as a fraction, then we call it irrational number. Irrational number. So for example, square root of 2, square root of 5, the square root of this kind of number are called irrational numbers. Square root of 2, square root of 5, and like pi. Right? I think you are familiar with this number, pi. Pi is an irrational number. It's a very famous irrational number, right? Pi. Pi. And if the number is irrational, the decimal representation is not repeating, okay? So we know that pi is about 3.14159, and I cannot remember the remaining thing, okay? But pi is about 3.14. Actually, this is an irrational number, and it's endless. This number is endless, right? It's endless. It's endless. Pi is an irrational number. Yeah, this is a famous irrational number. And what else can you think? Can you remember? What else? What else? Can you give me more irrational numbers? E. Still remember this number? Have you learned this in high school? E is called natural number. E. E. This is also an irrational number. E. Actually, E is an irrational number, sometimes called Euler's number. It's called, actually it's about 2.7. Okay, it's about 2.7. Sometimes it's called Euler's number. Okay, E is an irrational number, so actually it cannot be written as a simple fraction. And E is the base of the natural exponential function. And I think you have learned this when during high school. Okay, when you learn the functions like natural exponential function and something like y equals e to x, the E here is a natural number. Okay, E is about 2.7. It's a number about this. Okay, if you forget, find some material online. Okay, find some online materials to see this number. Okay, to see this number. Okay, and yeah, it's about 2.71828. Yeah, it's an irrational number. It's endless. Okay, it's endless. It's endless. Why we need this E? Actually, if you we well, later we will learn some practical problem like people's populations growth. The people's populations growth is an exponential growth. Actually, it's an natural exponential growth. So E is an important number when we try to compute some practical problem like people's the population of a country. Okay, the population of a country is when we try to compute. Okay, the population of a country, we will see E. We will see E. It's an exponential growth. Okay, exponential growth. Okay. Anyway, E is an important irrational number. It's about 2.7. 2.7. Pi is also an important irrational number. When we try to find the area of a circle, we need pi, right? And when we try to find the circumstance of a circle, we also need pi. Okay. Yeah, the circumstance of a circle is 2 pi r. Yeah, you are right. Okay, so these are the different types of real number. Okay, these are different types of real number. Okay, different types. Okay, next you should know what is a function. Okay, what is a function? The second important fundamental concept is a concept called function. Okay, function. I cannot stop the comment section. Okay, because that's because of the system. Okay, I cannot do that. Okay. Okay, next concept you should know is function. The fundamental concept of function. What is a function? Actually, a function is a rule. Okay, a function is a rule. For example, height is a function of age. Height is a function of age. Temperature temperature is a function of date. Okay, temperature is a function of date. And actually the area of a circle is a function of its radius. So actually, function actually is a rule. Okay, function is a rule, is a rule, is a rule. So for example, so we always write it like this: y is a function about x. Here, y is a function about x. So actually, here f is the rule. Okay, f is the rule. Is a rule. So for example, when we write y equals x squared, this is a function. Okay, this is a function. This is a function. Say when x equals 1, y equals 1. When x equals 2, y equals 4. So actually we give a rule. Okay, we give a rule. A function f is a rule that assigns to each element x exactly one element. So when x equals 1, we get only one y. We get y equals 1. When x equals 2, y equals 4. So we give a rule. So this is a function. Here, and we call x input, y output. So given input and give a rule, we get an output. Okay, we get an output. And sometimes x is also called independent variable. Independent variable. Y is called dependent variable. Dependent variable. Okay, dependent variable. And also, as I mentioned, we know that the area of a circle is a function of its radius, right? And for example, the area of a circle is a function of its radius. Suppose the area of a circle is A. Here we use A to represent the area of a circle. Okay. A is the area of a circle, and we say radius to be r. So you should know the formula. Okay, we know that A, you learn it in high school. A, the area of a circle is equal to pi r squared, right? A is equal to pi r squared. So here, A is a function of r. A is a function of r. We give a rule. Actually, we give a rule. Okay, A is a function of r. Here, r is the input. A is the output. Okay, A is the output. And when you learn function, you should know the concept like domain of a function. What is the domain of? What does domain mean? What does domain mean? The domain of a function actually is the set of all inputs that makes the function makes the functions, how should I say, the domain. So for example, so let's make the function satisfying. Okay, So for example, for this one, a equals pi r squared, what is the domain? So r can be, so here actually r can be any number, right? R can be any number. R can be here the domain of this function, for example, a equals pi r squared. Here r can be any number. So r can be any number. Here r can be any number, okay. Domain of this function, actually, here r can be any number, okay. And how about what is the domain of this one? So let me give you an example. Another example, okay. For example, this one, y equals square root of x. So what is the domain of this function? What is the domain of this function? This is y here is the square root of x, right? Right? Y is square root of x. So x, the domain means the range of x that makes the equation holds, okay. X is the input. X is input. Is the input, okay. Y is output. Here x must be non-negative, okay, for this one. So here x cannot be negative. Here x should be positive or equal to 0. Yeah, y is output. Y is output. Here x must be non-negative, okay. Here x must be non-negative. Actually, the domain of a function is the set of all x that makes this relation meaningful. Okay. Let me write it on the page, okay. So the domain of a function is the set of all inputs that makes the relation meaningful. This is the domain, okay. So for example, the previous example that I mentioned, this one, y equals square root of x, here for this one. So the set of all x that makes the relation meaningful. So what is the change about x? So here x cannot be negative. X is positive or equal to 0. When x is positive or equal to 0, y equals square root is meaningful, right? When x is negative, we cannot find square root. We cannot find square root, right? Get it? Get it? Get it? Okay, so you should know how to find the domain of a function. For example, this one. For example, this one. This is also a function, y equals 1 over x. This is a function. What is the domain of this function? What is the domain? Suppose y is 1 over x, 1 over x. What is the domain of this one? Yeah, y equals 1 over x. 1 over x, 1 over x. Here, when x is not 0, y is meaningful. Yeah. So when x is not 0, when x is not 0, y is meaningful. Yeah. It's the, yeah, some student write r except 0. Good, good. So here is the set of all real numbers except 0. So I should say this, okay. It's the set of all real numbers except 0. Yeah, you can also write in as interval notation. It's the set of all numbers except 0, except 0, okay. So x cannot be 0 for this one. So you can write it like as a set, as a set. This is the set notation. This is the set notation. Set notation, okay. We write it as a set. Or sometimes you use interval notation. Interval notation like this. Negative infinity to 0, union 0 to infinity. This is the interval notation. It means the set of all numbers except 0. This is the domain of the function. So when x is not 0, this function is meaningful, okay? It's meaningful. So x cannot be 0. X cannot be 0. Okay. Actually, I think you have learned many functions. You have learned many basic functions when you are in high school. Okay. So let me do a review of them. Okay. You should. So first, let me write it like this. Basic. Next, we need some basic functions. Okay. You should know some basic functions. So for example, the first one, y equals x. Okay, this one. This function actually it's a power function. Here the power is 1. It's a power function. Here the power is 1. Okay. The general power function, okay. So first kind called power function. So y has the form like this, y equals x to n. Here, this is a power function. Power function. And here n is the power. let's start from the simplest case. When n equals 1, y equals x, y equals x. And this function is also important. This function, y equals x, is a linear function. Sometimes we call it linear because this kind of function, the graph of the function, it's a line. The graph of this function is a line. And you should know how to draw the graph of this kind of function. This basic kind, okay. This one is called linear function. Okay. The graph of this kind of function is a line. It's a straight line. You should know how to draw the graph of a linear function. Okay, a linear function. Okay, now let's draw the graph. Okay, let's draw the graph. Okay. Okay, in order to draw the graph, you will use special points. So find some points on this. Okay, so this is the points. So for example, it passes through. In order to draw the graph, first you draw an LY plane. Okay, like this. This is an LY plane. And to draw the graph, we find some special points first. The graph of this. Okay, find some special points on satisfying the equation. So for example, when x equals 0, y equals 0. Okay, and when x equals 1, y equals 1. And you can draw more points. Okay, for example, when x equals 2, y equals 2. So the first point, origin, 0, 0. Okay, second, 1, 1. Last one, 2, 2. Then link it and stretch it. Okay, you will get a line. So this is the graph of this kind. Okay, this kind. The graph of this. You can use some special point to draw the graph. Okay, and this kind of function is called linear function. Okay, linear function. Actually, it's the power function with power 1. It's a power function with power 1. Okay. The graph of a linear function is a straight line. And some harder case like 2x plus 3. Here is also a power function. So this can be also see as a power function. Okay. Here it's the sum of a power function and a number. Okay. Here the power is also 1. So actually this kind is linear. So the graph of linear function is a straight line. Linear function. And how about this? Power. Here here is a function of power 2. Okay, a power function with power 2. Still remember this kind? This is called, I don't know whether you know it, it's called quadratic function. Quadratic function, okay, quadratic function. The graph of this kind is very famous. Okay, you should know how to draw the graph of this kind. The graph of a quadratic function is a parabola. It has U shape. U shape. You should know how to draw the graph of this kind, okay? The graph of y equals x squared. Y equals x squared. Actually, if you find some special point, then you can draw the graph, okay? The special point, for example, it passed through 0, 0, it passed through 1, 1, it passed through 2, 4, and more points, okay? Negative 1, 1, negative 2, 4, okay? So it passed through this 1, 1, 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. Here. And link it, stretch it, you will get a parabola. Parabola. So this is the graph of a quadratic function. Quadratic function. It's a parabola, okay? It's a parabola. It's a parabola. The graph of a linear function is a straight line. The graph of a quadratic function is a parabola, okay? It's a parabola. It has this kind of shape. It's a U shape, okay? It's a U shape. U shape. Because when x equals 2, y equals 2 squared, so 2, 4, 2, 4. It passes through the point 2, 4. Y equals x squared. You can find the corresponding point. Yeah, when x equals 2, y equals 4, right? When x equals negative 2, y equals 4. So you can find some special points like this. Then you can draw the graph. You can draw the graph. Draw the graph. Draw the graph. Okay. Now I want you to know how to draw the graph of this kind. See this? I think you should learn this before. This one. The third one. The first one is a linear one. Then now let's see the second type. Y equals e to x. This is a different kind, okay? This is a exponential function, and this is a special exponential function with base e. Actually, the exponential function, this is a natural exponential function. Let me write it more general, like this. Y equals a to x. A is a number. A is a number which is not 1. And a cannot be 1 and 0. Let me check. Wait a minute. Exponential function, okay. Oh, a is positive. The base, positive. A is called base. X is the power. This is an exponential function. Yeah, it's called exponential. I hope you still remember this math word, okay. Exponential function. Exponential function. Exponential function. Still remember this? So for example, when a equals 2, we have this. Y equals 2x. 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 Okay. 2x. 2x. Here, this is the exponential function. And here the base is greater than 1. Is greater than 1. When the base is greater than 1, the function is increasing. Yeah, it will go up. It will go up by y-axis. When base is greater than 1, we have this conclusion. Okay, here 2 is greater than 1. And how can you draw the graph? Actually, you use some special points too. Special points, okay. So when x equals 0, what is y? I think you should learn this before. 2 to 0 is 1, okay. Any number raised to power 0 is 1. Any number raised to power 0 is 1. 2 to 0 is 1. So it passes through 0, 1. Right? It passes through 0, 1. And it also passes through 1 when x equals 1. When x equals 1, y equals 2. Y equals 2. Okay. When x equals 2, when x equals 2, y equals 2 squared is 4. And when x equals 3, 2 cubed is 8. Okay. So as you can see, when x is getting larger, y is getting larger, right? When x is getting larger. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. Okay, so as x gets larger, y gets larger. Y gets larger. So it's the graph, so it's an increasing function. So you can find the point on the graph, okay. 1, 0, 1. this point, then 1, 2, then 2, 4, then 3, 8. Okay, suppose it's here, okay. And link it, you get this. And actually, you can draw the graph of the left part. So when the power is negative, when x is -1, what is y? What is y? When x is -1, what is y? 2 to -1. I hope you still remember the property. 2 to -1 is 1 over 2 to 1. Actually, it's 1/2. Okay, so it passes through point -1, 1/2. -2. 2 to -2. It's 1 over 4. Okay, 1 over 4. The power rule, okay. So you can find more points on the graph. So it looks like this. The graph looks like this. So this is the graph of this exponential function. This exponential function. Okay, now it's your turn. Okay, please draw the graph. Please draw the graph. Okay, draw the graph of y equals, let me think. Okay, can you draw the graph of this one? You draw the graph, then upload your, take a picture of your work, then upload in the group, then I can check, okay, then I can check. Please draw the graph, okay. You need to know how to draw the graph of some basic functions, like the power function, the basic power function like linear one, power 1, okay. Then the graph of quadratic function, and here the graph of an exponential function. So please draw the graph, okay, draw the graph. draw the graph and upload the picture. Take a picture, okay? Then upload the picture in the group, okay? Then I can check. Take a picture and upload in the group. Let me see your work, okay? See your work. I mean, you draw the graph, okay? The graph is similar to this one, right? It's similar. You need some points, okay? You still need some points. For example, the path through 0, when x equals 0, y equals 1. When x equals 1, y equals 3. When x equals 2, y equals 9. And some negative number, okay, when x equals -1, y equals 1/3. When x equals -2, it equals 1/9. 3 raised to power -2 is 1/9, okay. Then you use these points, okay, 1, 0, 1, 1, 3, then 2, 9. Suppose it's here. Then here, -1, 1/3, -2. It looks like this. Yes. Good. 3. Yeah, you are right. Yeah, 327. Good. It passed through 327. 2, 9, 1, 3. Yeah. So the graph looks like this. So it's increasing. So actually the shape of the exponential function looks like this, okay? It has this kind of shape. Good. Okay. Okay. Now let's take a break, okay? Try to sign the class. Let me open the take attendance, okay? Take attendance. Let me try it. Okay. Can you see a sign message? Can you see a sign message from your screen? Okay. Can you see a sign message from the screen? Okay. Then sign it. Okay. Sign the class. Sign the class. Yeah, I can find your names. I can get your names. Now 19 people have already signed the class. 19 people. 19, okay, 19 students. 19 students. Uh, 19 students have already signed the class. Okay, after you sign, you can take a break. Okay, take a break. You can see I think you should see a sign message from your screen. Then click it. Then click it. Then you can sign. Then you can sign. Okay. If you cannot sign, tell me. Okay. If you cannot sign, tell me. Tell me. You should see a sign message. Says, okay. 19 students have already signed the class. Take a break. Okay. Take a 15 minutes break. Okay.